Welcome to Sir Robert Chiduk Tutorials. Learning is 24/7. Hello and welcome to Sir Robert Chiduk Tutorials. Today we continue with our lesson in anatomy and physiology of the human body. We are going to look at the concept of homeostasis. We are going to be asked one day to define homeostasis. To define what homeostasis is. So homeostasis generally refers to the composition of the internal environment and how it is tightly controlled in a steady state. So the composition of the internal environment is tightly controlled, and this fairly constant state is called homeostasis. So the conditions of the internal environment are tightly controlled. What are these conditions? We have the condition of the temperature. It is tightly controlled within narrowly controlled limits. So it's impossible that everyone can have the same temperature. But we do have what we call a normal temperature, and it falls within certain limits, narrowly controlled limits. For example, if someone has got a temperature of around 36 degrees Celsius to 37.2 degrees Celsius, it's within narrowly controlled limits in homeostasis. So it is homeostasis which controls that temperature within narrowly controlled limits of 36 to 37.2 degrees Celsius. So you can see that the internal environment is tightly controlled in a fair constant, but it's relative. It doesn't mean that we can have everyone having the same temperature. The same goes even to, so what are some of these variables that are tightly controlled? With the variable of temperature, with the variable of water and electrolyte concentration, with the variable of pH or acidity or alkalinity of body fluids. We've got the variable of blood glucose levels. We've got the variable of blood and tissue oxygen and carbon dioxide. So homeostasis plays a crucial role in regulating all these variables to ensure that they are within narrowly controlled limits, they are within the optimal and acceptable levels that do not affect or damage the cells or the human body, as we are going to see. So literally the term homeostasis means unchanging, but in practice it describes a dynamic, ever-changing situation kept within narrow limits. This is what I was saying when I said the variables of temperature, the variables of blood pressure, the variables of glucose, pH, and other conditions. They are kept within narrowly controlled limits, within normal parameters by homeostasis. For BP to be within the normal ranges of, for example, 110 over 70 millimeters of mercury to around 120 over 80 millimeters of mercury, that normal blood pressure is kept within those narrowly controlled limits by homeostasis. For you to have a normal pulse rate is because of homeostasis. For you to have a normal pH in different body parts, it's because of homeostasis. So generally, when these variables go beyond normal and they become abnormal, it means there's homeostatic imbalance. So when this balance is threatened or lost, there's a serious risk to the well-being of the individual. For example, if the glucose level, maybe it goes up, because the normal limits for blood glucose level is 3.5 to 8 millimoles per every liter of blood. These are the normal readings for blood glucose level. And this happens because the internal environment is being maintained by homeostasis. So homeostasis is generally a self-regulating process whereby the body is able to monitor the internal variables of temperature, pulse, and so forth within narrowly controlled limits in a fairly steady state. So I think I've shown you some of the important variables which are maintained within narrow limits by homeostatic control mechanisms. So homeostasis is maintained by control systems that detect and respond to changes in the internal environment. So now this is answering your question. Obviously, we're asking, how does this homeostasis control temperature? How does this homeostasis control blood glucose level? How does it control blood tissue oxygen, blood tissue carbon dioxide? How does it control the blood pH, which is the acidity and alkalinity of blood? So now, for homeostasis to be able to monitor the conditions or the variables of the internal environment, it uses what we call the control systems. And in these control systems, we have got the detector. It detects and also it responds to changes in the internal environment. So there are detectors and also there are responses to the internal environment in order to control the changes that happen in your body. So a control system has three basic components. Now let us look at the control system and the components that it has. A control system has got a detector, 1, 2, a control center, 3, effector. So a detector is the one that recognizes that there is a change in the levels of a particular variable. There's a change to your temperature, there's unfavorable change to your blood pressure, there's unfavorable change to your pulse, unfavorable change to your blood tissue oxygen, and this can potentially damage your cells and tissues. So this is the detector now, which is detecting the abnormalities in the variables of the internal environment. When that happens, the information now which is detected is sent to the control center, which is in the brain. So the control center is able to see, detect, and evaluate, is able to evaluate and send a response in order to negate and control that situation. And that happens through an effector. An effector is there now to ensure that the changes that are supposed to be done happen to control the internal environment. So the control center determines the limits within which the control center determines the limits within which the variable factor should be maintained. It receives an input from the detector or a sensor and integrate the incoming information. So this is what happens. The detector takes the form of sensors. So the body has got sensory nerve endings that are going to detect changes in temperature, that it's hot or it's cold, and send that information to the control center, which is in the brain. So when the brain now responds, it integrates, evaluates the information, and sends the information to the effector organs that will then control. So when the incoming signal indicates that an adjustment is in need, the control center responds and it sends its output to the effector. So there's a dynamic process. This is a dynamic process that allows constant readjustment of main physiological variables. So in order to ensure that you are able to fully understand this, I'm going to explain using a diagram. And generally, homeostasis happens through two processes. There's two mechanisms. We've got a mechanism called negative feedback mechanism, and another one called the positive feedback mechanism. Because like I indicated earlier on, an abnormality in the internal environment is detected through the sensor nerve endings. The information is sent, the signals are sent to the control center, which is in the brain, right? The information is evaluated and integrated, and an output or the feedback is sent back to the effector organs. So this is where the negative feedback mechanism kicks in. It becomes negative feedback mechanism in the sense that the control center will be going against what is happening. So it's called negative feedback mechanism because we are trying to control the abnormality. We are going against what is happening. So it is called negative feedback mechanism because this output from the brain or the control center is to control what is really going on. It is to reverse or to negate. So it becomes negative feedback mechanism. So let us look at negative feedback mechanism and how it works under homeostasis. In systems controlled by negative feedback, the effector response decreases or negates the effect of the original stimulus, maintaining or restoring homeostasis. Thus, the negative feedback. Control of body temperature. So let us look at this now. So like I indicated earlier on, in systems where negative feedback mechanism works, the effector response decreases or negates the effect of the original stimulus. So the original stimulus response is going to be decreased or negated by negative feedback mechanism. For example, if the temperature was too high, right, that temperature is going to be decreased through negative feedback mechanism following the information from the brain to reverse that temperature from the control center. If the temperature is too low, it is going to be reversed and decreased following the signals from the control center, which is most of the times the brain. So now we want to look at the control of body temperature. We use the example of temperature as one of the variable conditions, but temperature is not the only variable which is controlled. Take note of this. Temperature is not the only variable which is controlled. We have blood glucose level, oxygen tissue, blood oxygen, tissue oxygen. We also have blood tissue carbon dioxide. We also have blood pressure and other internal conditions. But for the purposes of simplicity and for you to fully understand, we are going to look at the control of body temperature by homeostasis and negative feedback mechanism. So I want you to look at this diagram quite clearly and see what is going to happen. I want you to see here. So you can see that here we have got the detector, which is the thermostat. Then we have got control center, which is the boiler control unit. Then we have got the effector, which is the boiler. And then we have got the room temperature. We've got the room temperature, yes. So here we are basically looking at this using the example of a room temperature and how it is controlled by a thermostat, right? So now let us look at this. I think if you look below, you will see that the room temperature, right, you can see where there's a minus and where there is a plus, right? So that is going to show when the temperature is high and when the temperature is low, right? So when the room temperature is too low, right? When the room temperature is too low, it is going to be, when the room temperature is too low, right? When the room temperature is too low, let me highlight here. When the room temperature is too low, right? Right? It is detected by the detector here. You can see this plus because the room temperature is too high. So it is going to be detected by this detector, right? Because the room temperature was too low. When the room temperature is too low, here our room temperature, let me indicate our room temperature is way too low. Yeah, so our room temperature is way too low, as you can see here. This is our room temperature, which is way too low. Can you see this? It is way too low. Now that is way too low, all this information is going to be detected by the detector. This information is going to be detected by the detector. It's going to be detected here, right? Can you see now? This is our detector, right? Which is the thermostat in this case. I think you have seen that. So what is going to happen? The detector now is going to send information, right, to the control center. So this is our control center, right? The information from the detector is going to be taken to the control center, which is here. So this is our control center. In this case, the control center is the boiler control unit, right? I think you have seen that. Right? So the control center is going to reverse the high temperatures. You see that the arrow is pointing downwards. The arrow is pointing downwards to the effector. The effector is the one that is going to implement the changes. As you can see. So this is our effector, which is the boiler. So this boiler is going to decrease the temperature. You are going to see this. So what is going to be the outcome? The outcome is that the room temperature is going to decrease. So there's gradual heat loss from the room. Right, by the same process, if the room temperature is way too high, as you can see here. Now I'm explaining another aspect. If the room temperature is way too low, as you can see here, right? So the information is going to be taken to the control center again, right? To the control center. So when the control center sees that information to see that the temperature is way too low, so the information will again go to the control center. The control center will interpret or integrate the information and send the signals to increase the temperature to the effector, which is the boiler. So the boiler will increase the temperature. As you can see here, the room temperature indicated by this arrow, it is now increased, right? Here, it is now increased. I think you have seen that, right? It is now increased here. So I think you have seen that arrow. So this is what happens under negative feedback mechanism. So that was an example of the negative feedback mechanism control of room temperature by a domestic boiler. So this is similar to this non-physiological example of a domestic central heating system can be likened to the human body, right? If your temperature is too high, the central nerve endings are going to send the information to the brain, and then the brain is going to interpret, right, and reverse that high temperature. The information is sent to the hypothalamus, which regulates temperature. So the hypothalamus the signals from the hypothalamus will be sent to the effector organs to your body in order to reduce the temperature. So generally there's going to be vasodilation, your pores are going to open, and also you are going to produce sweat in order as a cooling mechanism, and the temperature decreases. If your body's temperature is way too low, this information is detected by the sensory nerve endings. The information is sent to the brain, which is the control center. The brain will interpret that information and send its signals to the effector organs, which are the skeletal muscles. You start shuddering and shivering. Shivering is a way of generating heat, right? As part of negative feedback mechanism. The moment you start shivering, it's a normal body mechanism of generating heat. That is number one. Number two, your pores are going to close in order to ensure that you don't catch the cold. Number three, your hairs are going to stand up instead of them just remaining. They are going to stand up in order also to prevent cold. And then four, you are going to develop a goose flesh, right? It's all those are mechanisms of increasing temperature. And also this is also going to activate the behavioral mechanisms whereby you start looking even for jerseys and other things that can make sure that you are warm. So this was the negative feedback mechanism. This was negative feedback mechanism. Now I want to look at what we call the positive feedback mechanism. There are only a few of this cascade or amplifier system in the board. So the positive feedback mechanism, is the opposite of negative feedback mechanism. In what sense? The negative feedback mechanism reverses the stimulus. It negates the stimulus. It goes against the stimulus, right? It corrects the situation. It reverses the situation. If the temperature is high, it reverses it. If the temperature is low, it reverses that. If the BP is high, it decreases it. That is negative feedback mechanism. Now when we are looking at the positive feedback mechanism, the situation is different. The positive feedback mechanism, if the temperature, for example, is high, the positive feedback mechanism will continue increasing it. So it amplifies what is there. It amplifies the stimulus. It increases the stimulus. That's why it's called the positive feedback mechanism. So there are only a few of these cascade or amplifier systems in the board. In the positive feedback mechanisms, the stimulus progressively increases the response. So in negative feedback mechanism, positive feedback mechanism, the stimulus progressively increases the response, so that as long as the stimulus is continued, the response is progressively amplified. Examples include blood clotting. For example, blood clotting is uses positive feedback mechanism so that the clot is formed, right? Because if positive feedback mechanism doesn't happen and the clotting mechanism is reversed, it means you continue bleeding. So if you develop a wound, right, and you start bleeding and the platelets start coming to the zone of injury, the clotting mechanism should proceed uninterrupted until a stable clot has been formed in order to prevent further bleeding. So that now, for that process to be amplified and progressively increased, that stimulus of facilitating the clotting mechanism, for it to continue, there must be a positive feedback mechanism which increases, which amplifies, right, that stimulus. And that is the positive feedback mechanism which mediates that process. So in blood clotting, there is positive feedback mechanism. And then we want to go to the women in delivery. When a woman is in delivery and that woman is in labor, with what we call the contractions, right? For a baby to be born, there must be what we call uterine contractions. The uterine contractions are the ones that will propel and ensure that the babe is pushed along the uterine tract and the birth canal, right? So those uterine contractions, once they start as a stimulus, they mustn't stop. They must continue and continue until a babe is born. So for that to happen, the stimulus must be increased, must be amplified. So you see that the midwives will even ensure that they will monitor to see if the the uterine contractions are continuing in their intensity, right? So because of that, the positive feedback mechanism is very important to ensure that the uterine contractions continue to increase. So in this case, positive feedback mechanism is very important. So like I explained earlier on, during labor, contractions of the uterus are stimulated by the hormone called oxytocin. So oxytocin, this hormone, is the one that stimulates uterine contractions. These force the baby's head into the cervix of the uterus, stimulating the stretch receptors there. In response to this, more oxytocin is released, that is through the positive feedback mechanism, further strengthening the contractions and maintaining labor. After the baby is born, the stimulus, which is the stretching of the cervix, is no longer present, so the release of oxytocin stops, right? So this was the positive feedback mechanism. So what is the summary of homeostasis, negative feedback mechanism, and positive feedback mechanism? We have learned that homeostasis is a process whereby the conditions of the internal environment are monitored and maintained within narrowly controlled limits, right? That is homeostasis. And we've seen that homeostasis works with the two mechanisms, that is the negative feedback mechanism and the positive feedback mechanism. What did we learn from the negative feedback mechanism? The negative feedback mechanism is a mechanism that reverses the status quo. It negates the stimulus. It opposes the stimulus. That is, if the temperature is high, that temperature is reversed. So how does this negative feedback mechanism work? How does it work? How does it reverse the temperature? How does it reverse the blood pressure? How does it negate the original stimulus? It works with the control center, right? It has got systems. It has got the control center, the detector system, the control center, and the effector system. This is what we have learned. The detector, in form of sensory nerve endings, detects the changes in the internal environment and sends the information to the brain, right? That information is interpreted by the brain, and the output or the feedback is sent to the effector organs. The effector organs will reverse the original stimulus, thereby producing a desired result. This is what we learn. Now let us go to the positive feedback mechanism. What did we learn in summary? We learned that the positive feedback mechanism increases the stimulus. It amplifies the stimulus, right? And we have seen major cases in which positive feedback mechanism is crucial. It is crucial in blood clotting because clotting mechanism should continue for some time until a clot is formed to prevent bleeding. It is also beneficial in labor for women that are delivering. The uterine contractions must be activated and there must be increased intensity for the baby to be propelled and for the head of the baby to engage into the cervix. So this is what we have learned, and how oxytocin is produced as a hormone that stimulates the uterine contractions. Until we meet again, thank you so much.